In this video, we're going to be looking at some scheduling problems. So these relate to what we covered in exercise 15D. And we're typically looking at things like finding the earliest start times or the latest start times or the critical path in an activity network. So we're going to kind of use a past exam question to help us out here. So this is just a network that I've copied from a past exam question. And it says this project involves 13 activities A to M. And this directed network below shows the activities and their completion times in days. So you can see we've got a pretty complicated looking network here, 13 activities altogether. And remember that when we read these, we can say things like from the start, activity A can begin straight away. Its duration is 4 days. And then activity D and activity E can begin as soon as activity A is finished, right? And so on. So that's how we interpret information from these diagrams. And it's really important, I guess, to know that there's lots of questions you might be asked about a diagram like this. So things like, what is the earliest start time or the latest start time of a particular activity? How long will it take to finish the whole project? Lots and lots of possible questions. The question that's asked will influence what technique you use to answer the question, and you always try to answer it in the quickest and easiest possible way. So it's a really good idea to always read ahead after you see a diagram like this to see what the questions actually are, so you can start thinking about which techniques you're going to use to answer the question. All right, so let's just start with one. This question, I've just made it pop up down the bottom here that says, what is the earliest start time for activity J? Okay, so activity J is here, and we have to figure out the earliest possible start time. Now, when you're asked about earliest start times or latest start times for a particular activity, the boxes method can be a good one, but it's important to note that you don't always need to do the boxes for every single activity in the whole network to answer the question. So if we're just trying to focus on finding out the earliest start time for activity J, well, we can, and in the next slide here, I've done all the boxes, so a double box next to every activity, but we're actually not going to use all of them. We're just going to do the ones we need in order to answer the question about the earliest start time for activity J. So as we kind of make our way through, let's start by looking at the path that J is actually on. Okay, so we can kind of do this in as little effort as possible. So remember that the way these double boxes work is that the box on the left-hand side gives the earliest possible start time. So basically the number we put in there is like, when can the activity start, as if we're starting it as soon as possible. So activity C comes from the start, which means it has an earliest start time of 0, right? It's allowed to start straight away. It's not waiting for any other activities to begin. The activity C takes 1 day to complete, which means that if it starts after 0 days and it takes 1 day to complete, well, 0 plus 1, that just means it'll finish after 1 day. So C is finished after 1 day, which means activity G over here, which is waiting for C to finish, that can start, the earliest time that can start is 1. Okay, so it can start after 1 day. And G takes 4 days to complete. So if it starts at 1 day, takes 4 days to complete, well, 1 plus 4 says that it finishes after 5 days. So if G is finished after 5 days, that means that J can start after 5 days. Okay. Now we did set up all the boxes and everything like that, but we're not going to go through and do any other boxes because we've got the information that we needed. What was the earliest start time for activity J? It's 5 days. Okay. So like I said before, you use the technique that's going to get you to excuse my bad handwriting. Use the technique that's going to get you to the answer with the least possible amount of effort. All right. Okay, let's have a look at another question that we might have been asked here. So, oops, that was the same one. Okay, so here's the same network, same information, but this question says, what is the overall completion time and which activities are on the critical path? So a very different question here. What we're trying to figure out here is, okay, if we have to get everything done to get the whole project finished, how long is that going to take? Now you can use the double boxes to work it out, but it's actually not the most efficient method. The best method here is actually to go through and find the length of each path. Okay, so as we go through, and I've realized I intended these to come up one at a time. They're going to come up all at once, but that's okay because I'll talk you through them. So as we go through, firstly, what I'll do is I'll highlight these one at a time and I can kind of just draw them onto the network. So The the possible paths from start to finish, when you work these out, I actually like to go from sort of like top to bottom. So I think about the highest sort of path you can go. There's no logic to that. It's just to sort of keep track of what you've already covered. So if we go A to D to K, right, that's a path from start to finish, A, D, K. So that's that one there. And that takes 14 days, right? 4 plus 5 plus 5 gives a total of 14. Right, so over here, this might be your working out where you write down the possible path and how long it's going to take. Then there's also another one, the next kind of one, and again, I'm just working from sort of top to bottom here. We could go along A, along E, along I, and then along K. So A, E, I, K would be another possible path. And when you add up the times of those activities, 4 plus 4 plus 2 plus 5 gives you a total of 15 days. Okay, it's going to start to get a bit messy here, so I'm going to get rid of those yellow lines. There we go. So next one, so we've done those sort of the two possible paths across the top. Next one will be the one straight through the middle, which is B, F, L. Okay, again, add up those times. 3 plus 7 plus 4 gives 14, so B, F, L is 14 days. Now we're going sort of down the bottom, and if we go C, G, J, M, right, that path has a total of 14 days. And lucky last, whoops, I've gone too far. Sorry about that. Lucky last, don't know why that happened. There we go, is CHM. All right, the one right along the bottom. So C to H to M, and that takes 1 plus 9 plus 3 gives 13 days. Okay, so what we've done here is we've mapped out all the possible paths from start to finish. Okay, to work out which one's the critical path, we actually just look for which one's the longest one. Okay, and quite clearly from our list here, the longest path is AEIK, which takes 15 days. That was this path here, AEIK. That is our critical path because it's the longest one. So basically, this shows like the time it's going to take for each individual path to be finished, but obviously the whole project's not finished until every single path is finished, because that means that every single activity is finished. So the overall completion time is 15 days. The overall completion time, 15 days. And which activities are on the critical path? A, E, I, and K. All right. Again, you'll do much better handwriting than me when you do your SAC, but that gives you a sense of how to work out the critical path or the overall completion time. And you can kind of see there's different answers to those questions, but they both rely on finding out the same information. Okay. Another way that question could have been worded is, which activities cannot be delayed without delaying the overall project. That would be another way of telling you the critical path. So there's a few ways that these questions can be asked, but the more you practice them, the more you'll pick up on the tricks. Okay, one last one for this sort of example is again the same activity network, but it's saying what is the latest start time for activity F. So for the latest start time, typically we do need to go back to the boxes, okay? But again, you only work out as many numbers as you need in order to get to the answer, and then you sort of stop after that. So what we're going to do here, and I'm going to kind of go through this relatively quickly, so you can always pause it and rewind it if I've gone through something a little bit quickly. But I'm going to go through and do all of the earliest start times for each activity, okay? And then we'll start working backwards and trying to figure out the latest start time for activity F. Okay, so we've got A, B, and C. They can all start straight away. So I'm going to put some zeros in here. If I follow on from A will finish after 4 days, which means E and D can both start after 4 days. Activity I is waiting for E. E starts at 4 days, takes 4 days to do, so 4 plus 4 gives me 8 for activity I. Now this is an interesting one. So D and I both kind of come together here before K can start. So let's have a look. D will finish after 9 days. I will finish after 10 days. Now if K is waiting for both of them, it has to wait until day 10 before it can start. So K's earliest start time is 10 days. We've got Through the middle, we've got activity B starts after 0 days. It takes 3 days to do, so that means F can start after 3 days. And F takes 7 days to finish, so that'll be finished after 10 days, which means L can start after 10 days. As we make our way through along the bottom here, so C finishes after 1 day, which means G and H can both start after 1 day. J, we worked this one out before. G will finish after 5 days, so J can start after 5 days. Again here, when we look at activity M, it's waiting for activity J to finish. That's going to finish after 11 days, because 6 plus 5 gives 11. H is going to finish after 10 days. So we've got H finishing at 10 days, J finishing at 11 days. That means M, because it's waiting for both of them, can't start until 11 days. I forgot to add the double boxes at the finish here, which are pretty important. So I'm just going to draw them poorly in here. So when we look at the finish time, and we already knew the answer from the previous question here, but K will finish after 15 days, L finishes after 14 days, M finishes after 14 days. So the whole thing's not finished until K finishes, which is going to be 15 days. So that's working through to get all the earliest start times. To get the latest start times, I'm going to use a different color here. What we do to begin with, not that big. What we do to begin with is actually just say, well, we want to make sure that we finish after 15 days, right? We want to make sure that we're not delaying the finish. So we put whatever the number was for the earliest start time there, we put the same number in the second box to say we want to finish at 15 days. And as we work our way backwards, we're going to try to fill in the latest possible time that the activities can start, but still making sure that the whole thing's going to finish in 15 days. Now, if we're focusing on activity F, right, the path that we want to look at first is the one that involves F on it. So let's go back to L. Now L takes 4 days to do, and it needs to finish at the latest by 15 days, right? So if we take 15 and we subtract 4, we get 11. In other words, this is saying that L can start after 11 days, takes 4 days to do, and so if it starts at day 11, it will still finish by day 15. So its latest start time is 11 days. Okay, so L has to start by day 11 at the latest. So when we work back and look at activity F, well, activity F takes 7 days to do. And if it has to finish by 11 days, well, 11 take away that 7 will give me 4, right? Or another way to think of it is, as long as F starts by day 4, takes 7 days to do, it's still going to finish by day 11. So it'll still finish in time for L to start when it needs to start. And now, yes, we could go back and do this with all the other numbers, but now we've actually got the answer that we want. So again, you don't go any further than the answer that you actually need. The question said, what is the latest start time for activity F? Well, the latest start time for activity F is going to be 4 days, right just above the question there. So 4 days is the latest start time for activity F. So for latest start time, the double boxes is usually your best method. And you try to focus, you cut as many corners as possible to try to get to the answer for the activity that you're being asked about.